January 8, 1998. American Astronomical Society meeting, San Diego, California. Dr. Sel Perlmutter is about to announce something that will break physics. Not bend it, not challenge it, break it. His team has been measuring the expansion of the universe using exploding stars as cosmic mile markers. They expected to find the expansion slowing down, gravity pulling everything back together, maybe heading for a big crunch, maybe coasting to a stop. Instead, they found this. The expansion isn't slowing down, it's speeding up. It's accelerating. Something is pushing the universe apart, and it's getting stronger. The audience doesn't applaud. They're too confused. This is like dropping a ball and watching it fall up, faster and faster, forever. One physicist stands up. There must be a mistake in your data. There wasn't. Meanwhile, 3,000 miles away, another team led by Adam Rees and Brian Schmidt has found the exact same thing, using completely different supernovae, different methods, different analysis. Same impossible result. Empty space isn't empty. It's full of something. Something that has negative pressure. Something that pushes instead of pulls. Something that gets stronger as space expands. They call it dark energy because they have no fucking idea what it is. Today we know 5% of the universe is normal matter. You, me, stars, planets, everything we can see. 27% is dark matter, invisible stuff that holds galaxies together. 68% is dark energy, the thing that will destroy everything. We live in a universe where 95% of everything is invisible, unknown, and actively trying to kill us. The 5% we can see, that's just the garnish on a cosmic horror sandwich. Right now, as you watch this, dark energy is pushing everything away from everything else. Every galaxy is getting lonelier. Every star is becoming more isolated. Every atom will eventually be alone in an infinite void. The universe isn't just dying. It's being murdered by empty space itself. And here's the part that should keep you up at night. It's not constant. It's getting stronger. 13.8 billion years ago, dark energy was negligible. 5 billion years ago, dark energy started dominating. Now, dark energy is 68% of everything. Future, dark energy will be basically 100%. In 100 billion years, all galaxies outside our local group will be invisible, disappeared beyond the cosmic horizon. Future civilizations will think the universe is just one galaxy surrounded by infinite darkness. They'll be wrong. The galaxies will still exist. They'll just be unreachable forever, like being buried alive in space-time. The universe's final joke. Everything that exists will still exist, but nothing will be able to see, reach, or know about anything else. It's cosmic solitary confinement for eternity. Einstein called it his biggest blunder, adding a cosmological constant to his equations to keep the universe static. He removed it when Hubble showed the universe was expanding. Turns out Einstein's blunder was removing his blunder. The cosmological constant is real. It's dark energy, and it's the most precisely measured disaster in physics. Welcome to Minutes of Existential Crisis with Math.
To understand how we discovered the universe is accelerating its own suicide, we need to talk about standard candles, Type 1a supernovae, and two teams of astronomers who hated each other. Type 1a supernovae, nature's standard candles. Imagine you're in a dark field. You see a light bulb in the distance. If you know it's a 100-watt bulb, you can calculate how far away it is by how bright it appears. Type 1a supernovae are nature's 100-watt bulbs. They all explode with the same brightness, always, every time, across the entire universe. How they work. 1. White dwarf star, dead star. Earth-sized sun's mass. 2. Companion star feeds it matter. 3. White dwarf reaches exactly 1.4 solar masses, Chandrasekhar limit. 4. Carbon fusion ignites everywhere simultaneously. 5. Entire star explodes in exactly the same way. 6. Peak brightness 5 billion times the sun. It's the universe's most reliable suicide bomb. Same ingredients, same explosion, same brightness. Every single time. It's like nature's McDonald's, depressingly consistent. The rivalry. Supernova Cosmology Project, Berkeley, led by Saul Perlmutter, physicists who learned astronomy. Methodical, careful, slow. The nerds. High Z Supernova Search Team, Harvard and Australia, led by Brian Schmidt and Adam Rees. Astronomers who learned physics. Fast, aggressive, competitive. The jocks. They hated each other, competed for telescope time, raced to find supernovae, published papers trying to scoop each other. Nothing motivates scientists like spite. Oh, you found 42 supernovae? We found 43. Suck it. Measuring the expansion. When galaxies move away, their light gets stretched, redshifted. Like the Doppler effect, but for light. The plan: find distant Type 1a supernovae, measure their brightness, tells distance, measure their redshift, tells speed, plot distance versus speed, calculate how expansion rate changes over time. Expected result: expansion slowing down due to gravity. Actual result: ha 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 ha, no! The impossible data. Both teams found the same thing. Distant supernovae were 25% dimmer than expected. This meant they were farther away than they should be, which meant expansion had accelerated. The teams checked everything. Maybe dust was blocking light? No. Maybe distant supernovae were different? No. Maybe redshift was measured wrong? No. Maybe the Earth is flat? No, that's a different conspiracy. The phone call. Late 1997. Perlmutter calls Schmeck. Are you getting weird results? Define weird. Acceleration. Fuck. When competing scientists agree their impossible results are the same, you know reality is weirder than their rivalry. The announcement. Both teams announce simultaneously. The universe is accelerating. Initial reaction from physics community. Denial. Anger. Bargaining. Depression. Acceptance. Nobel Prize, 2011. Einstein's zombie idea. 1917. Einstein adds lambda to his equations. Needed to keep the universe static. Called it the cosmological constant. Represents energy of empty space. 1929. Hubble shows the universe is expanding. Einstein removes lambda. Calls it his biggest blunder. 1998. Lambda returns from the dead. Explains acceleration. Value is 10 to the minus 29 grams per cubic centimeter. The most precisely measured, we don't know what the fuck this is, in science. Notice not as much sarcasm as before, because we're kind of out of flippant analogs and into the absolute strangeness of reality. The fine-tuning nightmare. Dark energy's value is exactly right for us to exist. 10 times stronger, no galaxies form. 10 times weaker, the universe collapses already. Current value precisely allows for 13.8 billion years of structure formation. The odds of this value by chance, 1 in 10 to the 120. That's like randomly guessing a specific atom in the observable universe on your first try, will blindfolded and trunk. The universe is either designed, infinitely lucky, or we're missing something huge.
Here's the embarrassing truth. We have no fucking idea what dark energy is.
We know what it does, we can measure it precisely, but asking what it is like asking what consciousness is made of. Prepare for frustration. Option 1, vacuum energy, the quantum nightmare. Quantum mechanics says empty space isn't empty. It's a boiling foam of virtual particles appearing and disappearing. This creates energy, vacuum energy, zero-point energy. Calculating vacuum energy from quantum mechanics, expected value, 120 times larger than observed dark energy. We're not off by a little, we're off by infinity. This is the worst prediction in the history of physics. It's like predicting a mouse and getting a universe-sized elephant made of explosions that exists in 11 dimensions. Option 2, cosmological constant, the boring answer. Maybe dark energy is just a property of space itself. Every cubic meter of space has a tiny amount of energy. Always has, always will. Problems. Why that specific amount? Why not zero? Why not infinite? Why exactly right for life? It's like finding the universe's thermostat is set to exactly 72.1337 degrees Fahrenheit, and nobody knows who set it or why. Option 3, quintessence, the dynamic darkness. Maybe dark energy isn't constant. Maybe it's a field that changes over time, like the Higgs field, but for destruction. Quintessence models suggest dark energy was different in the past, it's evolving, it might get stronger, big rip, it might get weaker, big crunch after all, it might oscillate, big bounce. So what will dark energy do? Yes, that's not an answer. Welcome to cosmology. Option 4, gravity is broken, the radical solution. Maybe there's no dark energy. Maybe gravity just works differently on cosmic scales. Modified gravity theories, MOND, modified Newtonian dynamics, FR gravity, TVES, tensor vector scalar gravity, emergent gravity. Gravity is made up gravity. Problem? They all have their own problems, and none fully explain the data. Let's fix dark energy by breaking gravity. But gravity works everywhere else. Details. Option 5, extra dimensions, the string theory special. String theory suggests 11 dimensions. We see 3 spatial plus 1 time. Where are the other 7? Maybe they're tiny and curled up. Maybe dark energy is leaking from them. Maybe gravity is leaking into them. Option 6, the anthropic cop-out. Maybe there's a multiverse with different dark energy values in each universe. We're in one where dark energy allows for life, because if we weren't, we wouldn't be here to ask. Why is dark energy perfect for life? Because if it wasn't, you wouldn't exist to ask. That's not an answer. It's the only answer we have. I hate this. Join the club. Option 7, phantom energy, the nightmare scenario. What if dark energy is getting stronger over time? Phantom energy has W less than -1, equation of state parameter. Normal dark energy, W equals -1. Phantom energy, W equals -1.1 or worse. If true, big rip in 22 billion years. Everything tears apart. What we actually know. From observations, W equals -1.03 plus or minus 0.03. Consistent with cosmological constant, but phantom energy not ruled out. Neither is quintessence. We know nothing. After decades of research and billions of dollars, we've precisely measured our ignorance. We know exactly how much we don't know. Progress.
Let's talk about how dark energy actually pushes things apart. Spoiler, it doesn't push. It's weirder than that. The expanding balloon. Imagine the universe as a balloon surface. Galaxies are dots on the balloon. As you inflate it, every dot moves away from every other dot. Dots farther apart move away faster. No dot is at the center. The space between dots expands.
Dark energy is like someone gradually increasing how fast they're blowing up the balloon. Negative pressure, the mind breaker. Normal matter has positive pressure. It pushes outward, but gravity from energy density dominates. Net effect, attractive. Dark energy has negative pressure. It pulls inward, but not really. But this creates repulsive gravity. Net effect, repulsive. So negative pressure causes expansion? Yes. That makes no sense. Correct. How does pulling cause pushing? General relativity is weird. The math of cosmic destruction. The Friedman equation a dot over a squared equals 8 pi g over 3 times rho minus k over a squared plus lambda over 3, where a is the scale factor, size of the universe, rho is energy density, k is curvature, lambda is the cosmological constant. As universe expands, matter density proportional to 1 over a cubed, so dilutes, radiation density proportional to 1 over a4, dilutes faster. Dark energy density is constant. Eventually, only lambda term matters. Exponential expansion forever. The cosmic power struggle. Radiation era, 0 to 47,000 years. Radiation dominates, universe opaque, expansion decelerating. Matter era, 47,000 years to 9.8 billion years. Matter dominates, galaxies form, expansion still decelerating but slower. Dark energy era, 9.8 billion years to forever. Dark energy dominates. Expansion accelerating. Structure formation ending. Loneliness beginning. The universe had a childhood, radiation, an adulthood, matter, and is now entering its emo phase, dark energy, where it pushes everyone away. The shrinking observable universe. The observable universe is getting bigger, more distance. But fewer galaxies are observable because they cross the horizon. Now can see galaxies 46 billion light years away. Future, horizon stops expanding at 17 billion light years. Far future, only gravitationally bound objects visible. Decider space, the universe's endgame. If dark energy is a cosmological constant, universe approaches decider space. Exponential expansion, constant temperature, 10 to the negative 29 Kelvin, maximum entropy. Nothing ever happens again. It's the cosmic equivalent of a sensory deprivation tank. Forever. The cosmic horizon radiates. Just like black holes, the cosmic horizon has a temperature. T equals h over 2 pi, where h is the Hubble parameter. Current temperature, 10 to the negative 29 Kelvin. Lower than cosmic microwave background, but in the far future, it's all that's left. The universe will end not in fire or ice, but in a lukewarm bath of quantum radiation from a horizon we can never reach. How poetic, how boring. The last structures. Dark energy is ending structure formation. No new galaxy clusters forming, existing clusters stopping growth, star formation rate declining, universe becoming sterile. Peak structure was 6 billion years ago. We're living in the cosmic autumn. Winter is coming, and it lasts forever. If dark energy is phantom energy, W less than -1, we don't get a slow heat death. We get the big rip. Everything, and I mean everything, gets torn apart. Let me walk you through the timeline of cosmic annihilation. 22 billion years from now, the countdown begins. Assuming W equals -1.5, middle phantom scenario, RIP minus 60 million years. Milky Way is torn apart. Stars drift away from galactic center, night sky gradually empties, stellar neighbors disappear. Sun becomes alone. Imagine looking up and watching stars disappear. Not dying, just
leaving, like the universe is ghosting us one star at a time. RIP minus 3 months. Solar system unbinds. Planets fly away from sun. Earth drifts into eternal darkness. Temperature drops to near absolute zero. If anyone's still alive, they're having a bad time. RIP minus 30 minutes. Earth explodes. Not from impact, from expansion. Gravity can't hold it together. Every rock, every drop of water flies apart. RIP minus 10 to the minus 19 seconds. Atoms tear apart. Electrons ripped from nuclei. Chemistry ends. Matter as we know it ceases. The Big Rip. Scale factor becomes infinite. Every point separated by infinite distance. Density approaches zero. Temperature approaches infinity. Physics breaks. Time might end. It's not death. It's unmurder. Everything that exists gets pulled apart into nothing. The universe doesn't just die, it unexists itself. Different rips for different W. W equals minus 1.1, big rip in 100 billion years. W equals minus 1.5, big rip in 22 billion years. W equals minus 2, big rip in 16 billion years. W equals minus infinity, big rip tomorrow, but we're still here, so no. Current constraints, W equals minus 1.03 plus or minus 0.03. Big rip possible, but not confirmed. The little rip, polite destruction. If W is just barely less than minus 1, bound structures eventually tear, but takes infinite time, gradual disintegration, slow cosmic decay. It's like the Big Rip, but with British manners. Everything still dies, but apologetically. The pseudo-rip, fake out. If dark energy increases, but then stabilizes, dramatic expansion, looks like a big rip coming, but stops just short. Structures survive, but barely. Universe continues, damaged. The universe threatens to kill everything, then goes, just kidding, and then only mostly kills everything. What a prankster. How to survive the Big Rip? Spoiler, you can't. Options considered by physicists. 1. Create pocket universe. Requires physics we don't have. 2. Modify local space-time. Requires energy we don't have. 3. Upload consciousness. Requires technology we don't have. 4. Time travel to past. Requires time machines we don't have. 5. Accept death. Requires maturity we don't have. The race to measure W. Current experiments: Dark Energy Survey, Euclid Space Telescope, Roman Space Telescope, Vera Rubin Observatory. Goal: measure W to plus or minus 0.01 precision. Timeline: next 10 years. Stakes: knowing how everything dies. We're spending billions to find out if the universe will die in a whisper or a scream. Money well spent. What else were we going to do with it? Solve poverty?
Let's talk about the most embarrassing failure in physics, the vacuum catastrophe. It's so bad, physicists pretend it doesn't exist at parties. The quantum vacuum. Empty space isn't empty. Quantum mechanics says it's full of virtual particles appearing and disappearing, quantum fields fluctuating, zero-point energy vibrating, probability waves waving. Every field contributes energy: electromagnetic field, electron field, quark fields, gluon field, Higgs field, fields we haven't discovered. The calculation from hell. Calculating vacuum energy, sum over all possible frequencies, up to Planck scale, 10 to the 19 GeV, include all quantum fields. Result: rho vacuum approximately 10 to the 113 ergs per centimeter cubed. Observed dark energy, rho dE approximately 10 to the minus 7 ergs per centimeter cubed. Difference: 120 orders of magnitude. We're off by more than the number of atoms in the universe. It's like measuring your height and getting 3 galaxies tall. Why this is a disaster. If vacuum energy was actually 10 to the 120 times larger, the universe would have expanded to infinity in 10 to the minus 35 seconds. No particles would form, no structures possible, no time for anything. Instant heat death. The fact you exist proves quantum mechanics is wrong, or incomplete, or lying. Solution 1. Supersymmetry, the elegant failure. Every particle has a superpartner. Electron to selectron, quark to squark, photon to photino. Bosons and fermions cancel exactly. Vacuum energy equals 0. Problem solved. Except no superpartners found. LHC has ruled out simple versions. If it exists, it's broken or complicated. We'll fix the vacuum by doubling all particles. Have we found any? No. Will we? Probably not. Great solution. Solution 2. The multiverse cop-out. String theory suggests 10 to the 500 possible vacua. Each has different vacuum energy. We're in one that allows life. Problems. Untestable. Explains everything, thus nothing. Feels like giving up. Makes physicists cry. Solution 3. Vacuum fluctuations cancel. Maybe vacuum fluctuations don't gravitate. Maybe gravity doesn't see quantum fluctuations. Maybe we're calculating wrong. Evidence against? Casimir effect shows vacuum energy is real. Evidence for? Universe exists. Vacuum energy must be real because we measured it. But it can't be real because we exist. So it's real but doesn't gravitate? Unless it does. This is why I drink. Solution 4. Dynamic cancellation. Maybe a field adjusts to cancel vacuum energy. Vacuum energy huge initially, quintessence field evolves, cancellation happens naturally, tiny residual equals dark energy. Problem requires incredible fine-tuning. Bigger problem, no evidence for quintessence. The coincidence problem. Why is dark energy similar to matter density now? Matter density decreases as A cubed. Dark energy density, constant. Ratio changing rapidly. But we happen to exist when they're comparable. Odds, astronomically small. Unless something we don't understand. Why is matter and dark energy similar now? Coincidence. That seems unlikely. The alternative is admitting we know nothing. Coincidence it is.
Let's talk about what dark energy means for life, intelligence, and any hope of cosmic civilization. Spoiler, it's not good. The Stelliferous Era. We live in the Stelliferous Era, when stars shine. Started 150 million years after Big Bang. Ends 100 trillion years from now. Peak star formation, 3 billion years ago, we missed it. Current phase, slow decline. Dark energy is closing the window for life. Star formation declining. Galaxies becoming isolated. Resources spreading out. Energy getting harder to harvest. We showed up to the party 10 billion years late, and it's already winding down. Classic humanity, late to everything, including existence. The final generations. Red dwarf stars live 10 trillion years. Last star forms approximately 100 trillion years from now. Last star dies 10 to the 14th years from now. Dark energy dominates everything after. Future civilizations will know only their own galaxy, if bound, no evidence of Big Bang, no other galaxies visible, universe appears static and eternal. They'll be completely wrong about cosmology. The prison of local groups. Dark energy makes intergalactic travel impossible. Galaxies receding faster than light. can never catch them, even at light speed, forever isolated. Current window for intergalactic travel, 20 billion years. After that, every galaxy cluster is permanently alone. Let's colonize other galaxies. We have 20 billion years. Plenty of time. We haven't even colonized Mars. Fuck. The last messages. Signals sent now to galaxies. 10 billion light years away, arrives, but barely. 15 billion light years away, never arrives. 20 billion light years away, physically impossible. Future civilizations can't even communicate between galaxies. No galactic internet, no universal civilization. Just islands of intelligence in an infinite ocean. Boltzmann Brains, the ultimate insult. In de Sitter space, dark energy dominated, random quantum fluctuations occur. Rarely, they create structures, including conscious observers. Boltzmann Brains. Time until random brain appears, 10 to the 10 to the 50th years. Time until the universe ends, infinite. Therefore, most observers are Boltzmann brains. You're more likely to be a random fluctuation than evolved life. Am I real or a random quantum fluctuation? Statistically, you're random. But I have memories of a past. Random fluctuations can include false memories. I need therapy. Your therapist is probably also a fluctuation. Dark energy solves the Fermi Paradox. Why don't we see alien civilizations? Dark energy is the answer. Advanced civilizations are already isolated, can't reach us even at light speed. Their signals can't reach us. We're all prisoners in our local groups. The universe isn't empty, it's just that everyone is in solitary confinement. The Kardashev scale hits a wall. Type 1, planetary energy, achievable. Type 2, stellar energy, achievable. Type 3, galactic energy, barely achievable. Type 4, universal energy, impossible due to dark energy. Dark energy puts a hard cap on civilization growth. Maximum possible civilization, 1 galaxy cluster. No universal empires, no cosmic civilizations. We'll become a Type 4 civilization. Dark energy says no. We'll overcome it. With what energy? Type 4 energy? Circular logic is circular. The existential implications. If dark energy continues, the universe becomes cold and empty. All structures decay. Information is lost. Nothing matters long term. Heat death inevitable. Every civilization must face this. Finite resources, finite time, infinite isolation, inevitable death. How do you find meaning knowing everything ends? Desperate escape plans. 1. Create baby universes. Requires quantum gravity mastery. Might be impossible. No way to test. 2. Modify dark energy locally. Requires understanding we don't have. Energy requirements absurd. Probably impossible. 3. Upload to black holes. Use time dilation to outlive universe. Still die eventually, boring way to spend eternity. 4. Accept and make peace. Most realistic option, least satisfying, very Buddhist. Our options are impossible physics, impossible engineering, boring immortality, or Zen acceptance. I'll take impossible physics for $500, Alex.
Here's a thought that keeps cosmologists awake. What if dark energy isn't constant? What if it changes? What if it's changing right now? The equation of state parameter, W equals pressure/density. If W changes over time, W greater than -1, big crunch possible. W equals -1, heat death. W less than -1, big rip. And W oscillating, cyclic universe. Current measurement precision, plus or minus 0.03. Not good enough to detect slow changes. Quintessence, the dynamic dark energy. If dark energy is a scalar field, like Higgs, started at high energy, rolling down potential, currently at W approximately -1, could change in future. Possibilities: field reaches minimum, constant dark energy; field overshoots, oscillating universe; field reverses, big crunch; field accelerates, big rip. So what will happen? One of everything. That's not helpful. Neither is the universe. Tracker fields versus freezing fields. Tracker fields, W changes predictably, follows matter or radiation, eventually dominates. We can predict future. Freezing fields, W frozen at random value, depends on initial conditions, unpredictable, we're screwed. Evidence favors neither clearly. Phase transitions, cosmic mood swings. Dark energy might undergo phase transitions, like water to ice. Sudden change in properties could happen anytime, no warning. If phase transition occurs, best case is slightly different expansion. Worst case, vacuum decay, everything dies instantly. Most likely, we have no idea. The universe could fundamentally change its nature at any moment and we'd have zero warning. Sleep tight. Chameleon fields, dark energy with multiple personalities. Some theories suggest dark energy changes based on environment. Dense regions, hidden; empty space, active; near matter, screened; far from matter, full strength. This would explain why we don't see it in labs. Also explains nothing else, but sounds cool. What observations tell us? Looking back in time, 10 billion years ago, W equals -0.95 plus or minus 0.2. 5 billion years ago, W equals -0.98 plus or minus 0.1. Now, W equals -0.13 plus or minus 0.03. Consistent with constant, but error bars allow variation. Need better data. The next generation experiments. Euclid Space Telescope, launched in 2023, mapping 10 billion years of expansion, measuring W to plus or minus 0.02. Results, 2030s. Nancy Grace Roman Space Telescope, 2027, 100x Hubble's field of view, tracking 100,000 supernovae, precision W to plus or minus 0.01. Vera Rubin Observatory, 2025, entire sky every 3 nights, 10 billion galaxies tracked, dark energy changes detectable. Square Kilometer Array, 2030s, radio telescope array, tracking hydrogen throughout the universe, independent dark energy measurement. We're building bigger eyes to watch the universe die more precisely. It's like getting 4K video of your own execution. Dark energy interactions. What if dark energy interacts with dark matter? Could exchange energy, might explain coincidence problem, changes both evolution, currently no evidence. Normal matter, fifth force possible, would violate equivalence principle, tested to extreme precision, probably not. Itself, self-interactions could cause changes, might lead to dark energy stars, could clump in weird ways, pure speculation. Maybe it's not dark energy. Alternative explanations being tested. Massive gravity. Graviton has a tiny mass, changes propagation at large scales, makes the universe appear accelerating. Problem? Gravity waves say no. Galileans. Scalar fields with special symmetries, screen themselves near matter, accelerate expansion in voids. Problem? Too many free parameters. Void models. We live in a cosmic void. Looks like acceleration. Problem? Void too perfect. Also, CMB says no. Maybe we're wrong about everything. That's always possible. Should we consider it? After tenure. Let's take a journey to the deep future, when dark energy has won and the universe is dying its slow, cold death. Pack a lunch. And an existential crisis. The next trillion years. 100 billion years, last galaxies disappear beyond horizon. 1 trillion years, last new stars form. 10 trillion years, smallest stars still shining. 100 trillion years, last stars die. 10 to the 15 years, black holes dominate. 10 to the 40 years, black hole era. 10 to the 100 years, last black holes evaporate. 10 to the 1000 years, quantum tunneling era. 10 to the 10 to the 120 years, possible new Big Bang. The degenerate era, 10 to the 14 to 10 to the 40 years. Stars are dead, only remnants remain. White dwarfs, slowly cooling. Neutron stars, slowly spinning down. Black holes, slowly evaporating. Planets, frozen, orbiting nothing. Dark energy has separated everything. Each stellar remnant is alone. No new energy sources. Universe maximum size, 1 dead star. It's like a nursing home for stellar corpses, except the nursing home is infinite, the nurses are gone, and everyone's in solitary confinement. The black hole era, 10 to the 40 to 10 to the 100 years. Only black holes remain active. They evaporate via Hawking radiation. Universe is mostly empty space. Occasional photon from evaporation. Temperature 10 to the minus 30 Kelvin. A stellar mass black hole evaporates over 10 to the 67 years. Supermassive black holes 10 to the 100 years. The universe watches paint dry, except the paint is event horizons, and drying takes Google years. The dark era 10 to the 100 plus years. All black holes gone. Only leptons and photons remain. Infinite space between particles. Nothing happens. Ever. Temperature approaches absolute zero. Entropy maximum. Activity 0. Hope abandoned. Universe technically exists. The universe becomes a perfect vacuum with occasional electrons separated by distances larger than today's observable universe. It's like Detroit, but infinite. Quantum tunneling to new states. Given infinite time, protons might decay 10 to the 40 years. Quantum tunneling could create new structures. Iron stars might form from quantum tunneling. Eventually collapse to black holes. Cycle repeats. Time for iron star to form is 10 to the 1500 years. Poincare recurrence, the ultimate reset. Theorem: any finite system returns to initial state. Universe is finite. Observable part. Recurrence time 10 to the 10 to the 120 years. The universe could randomly reassemble itself into its initial state. You could randomly exist again, having this exact same experience infinite times. You might have watched this video infinite times already in previous universes. You always get to this part and think, that's ridiculous. You're predictable across infinite recursions. Vacuum decay, the quick death option. If Higgs field is metastable, could decay to lower state. Bubble of true vacuum expands at light speed, destroys everything it touches, rewrites the laws of physics, could happen anytime. Probability? Unknown but non-zero. Warning time? 0. Survival chance? 0. Baby universes. Cosmological reproduction. Quantum fluctuations might create new universes. Tiny regions undergo inflation, become separate universes. No communication with parent. Might have different physics. Our universe could be budding constantly, creating infinite babies that we'll never know about. The universe might be reproducing, and we're the cosmic equivalent of bacteria in the parent's gut, unaware of the birth happening. How humbling. The final state, de Sitter space. If dark energy is truly constant, universe approaches de Sitter space. Exponential expansion forever. Constant temperature, 10 to the minus 29 K. Event horizon for every observer. Maximum entropy achieved. It's the universe's retirement home. Nothing happens, nothing can happen. Perfect equilibrium. Perfect boredom. Forever. What does it mean?
If dark energy dominates forever, all accomplishments erased, all information lost, all structures dissolved, all meaning evaporated. Does anything matter if it all ends in nothing? Is temporary meaning still meaningful? Are we, the universe, experiencing itself briefly, or just random quantum fluctuations pretending to be conscious? Nothing matters because of heat death. You still have to pay rent. But in 10 to 100 years, rent's due on the 1st.
"68% of everything is dark energy. Right now, this moment. It's in this room with you, pushing atoms apart by amounts too small to measure, but too important to ignore." In the 90 minutes you've watched this, the observable universe has grown by 4 billion cubic light years. Galaxies have moved 100,000 kilometers farther apart. The universe has become lonelier by an amount that would take light 3 hours to cross. Every second, the expansion accelerates. Every moment, isolation increases. Every heartbeat, the universe becomes more committed to its own dissolution. We discovered this 26 years ago, a cosmic yesterday. We've known the universe is dying for less time than The Simpsons has been on air. But we haven't given up. Thousands of scientists, billions of dollars, massive machines pointed at the sky, all trying to understand what's pushing everything apart. Maybe we'll find dark energy changes. Maybe we'll discover how to stop it. Maybe we'll learn it's not what we think. Maybe we'll find meaning in the meaninglessness. Or maybe we won't. Maybe the universe really is accelerating toward infinite loneliness, and we're just smart enough to watch it happen, but not smart enough to stop it. The universe gave us consciousness just in time to realize everything is flying apart. It's like being born at a funeral for everything, where the funeral lasts forever and you're both mourner and corpse. But tonight, you can still see stars. Galaxies are still visible. The universe is still young enough for wonder. We exist in the brief cosmic moment when structures exist, stars shine, and minds can contemplate their own extinction. We won the temporal lottery. We exist when existing is possible. Dark energy is pushing everything apart, getting stronger, ensuring nothing lasts forever. But right now, this moment, we're still together, still connected, still fighting the darkness with science, with wonder, with stubborn refusal to go gentle into that cosmic night. The universe is 13.8 billion years old. Dark energy has dominated for 4 billion years. We've known about it for 26 years. You've known about it for minutes. What you do with that knowledge, in the face of infinite darkness, that's what makes us human. Welcome to a universe where 68% of everything is pushing you away. But you're still here. For now.